Okay, let's go ahead and talk about Newton's third law of motion. Whenever one object exerts a force on another object, the second exerts an equal and opposite force on the first. Now, an easier way to say this is that for every action, there is an equal and opposite reaction. For example, if you're kicking a soccer ball, you put force onto the soccer ball so that it can go. But if you'll remember a time when you did kick a soccer ball, you also feel the force on your toes. So you're giving a force by your foot kicking the ball, but the ball is also giving an opposite force, an opposite reaction back on your toes. And that's what this law is discussing. Now, there are two types of forces. There's an action force and a reaction force. So for every action force, like would be you kicking the ball, there's an equal and opposite reaction force, which would be what you feel on your toes. And so our example is kicking a soccer ball. Another example would be hitting a tennis ball with a racket. When you hit a tennis ball with a racket, you're providing a action force when the racket actually hits the ball. But if you'll remember, you also feel a vibration in the handle of the racket. That is the reaction force coming back down to your handle that you feel in your hand. Now, Newton's third law is all about momentum, and so we're going to calculate momentum. The formula for momentum is mass times velocity, and P is what we use to represent momentum. I know that's weird, but we couldn't use M because the small m is mass, and so we can't use the same letters. So P is used to represent momentum, and then mass times velocity. Now, the unit used for momentum is kilograms times meters per second, which is exactly the SI unit for mass and velocity. Now, we're going to go ahead and do some practice problems, and I want you to try these on your own first. Go ahead and try to make your own circle and try to do questions 1 and 2. Pause the video, and once you're ready to check your answers, resume the video. All right, let's go ahead and look at this. Now, our formula, if you'll remember, is P equals M times V. So your circle that you tried to draw by yourself this time should look something like this. Since M and V are next to each other, they have to be next to one another in the circle. All right, and let's go ahead and look at this answer. An athlete has a mass of 73 kilograms, and that athlete runs with a constant forward velocity of 1.5 meters per second. What is the athlete's momentum? So all you should have done was multiply 1.5 times 73, which should have given you a momentum of 109.5 kilograms times meters per second. Now, if you did not get this right, give me 1 second and I'm going to come and work these problems out. But if you did get them right, that way you could go ahead and move on. Now, if a car has a mass of 925 kilograms and it has the same momentum as the athlete above, what is the car's speed? So we're looking for speed, and the answer for this problem is going to be that it had a speed of 0.12 meters per second. All right, now I'm going to go back and actually solve these problems. So if you did not need help solving these, you can go ahead and fast forward the video. But if you do need help, stay and watch, and let's figure out how you got them wrong. Now, for this first one, an athlete has a mass of 73 kilograms running with a constant forward velocity of 1.5 meters per second. What is the athlete's momentum? And remember, we always write out the variables to tell us which one we have and which one we don't. And it said, what is the momentum? So we know we're looking for it. The mass was 73 kilograms. The velocity was 1.5 meters per second. Now we write our formula in letters, P equals M times V, then we fill it in with numbers, 73 kilograms times 1.5 meters per second, and that then equals, once you multiply them together, the 109.5 meters per second. Okay, now let's look at problem number 2. we're going to have the same three variables, P equals, M equals, V equals, and it actually tells us we're going to use the momentum from problem number 1. So we're going to use the same momentum that we discovered in problem number 1. It asks what is the car's speed, so we know we're looking for velocity, and it tells us that the car has a mass of 925 kilograms. So since we're solving for velocity or speed, we have V equals. And if you'll cover it up on your circle, you'll see that the formula for V equals is momentum divided by mass. So we'll go ahead and fill that in with our numbers. 109.5 meters per second. Oh, I'm sorry, I gave y'all the wrong units over here. The units for momentum, remember, is kilograms times meters per second. And that's divided by the mass of 925 kilograms. Once you divide that, you get the 0.12 meters per second. And if you're curious of how the units cancel out, just so you can see it, these kilograms cancel out. That's why the velocity then equals meters per second. But you don't have to know how to do that. Just always remember velocity is going to be meters per second, momentum will be kilograms times meters per second, and our mass will be kilograms. Now let's go ahead and finish up our notes. The last thing for us to discuss is the law of conservation of momentum. The total amount of momentum in an isolated system is conserved. The total momentum of two or more objects after a collision is the same as it was before the collision. So that just means that momentum is never created or destroyed. Same thing that we've talked about as far as law of conservation previously. Now, if you're having a hard time picturing or wondering what momentum is, think about if you're running down a steep hill. You know how as you run down a steep hill, it gets faster and faster, and the harder it is for you to stop, and that feeling of going faster and faster and needing to come to a stop, that's momentum. You're gaining momentum as you run down that steep hill. And so that might give you something a little bit to way to visualize what momentum is. Now, let's go ahead and summarize for today. And your summary today is a one-word summary. I want you to pick one word that encompasses the entire video from today. All right? And I hope you have a good evening, and I'll see you in class.